Okay? Yes or no? Yes or no? And then the denominator, you are going to have what? Difference of square, right? 5 squared minus 2i, the whole thing squared, which is 25 minus 4i squared. But what is I squared? -1. And the numerator, you need to multiply, FOIL it, and you get I squared. What is I squared? -1. So, many students did not simplify this in the final exam. What happened? Sorry, they would think that you do not have basic understanding of complex numbers. Usually, you will have quite a lot of points off. Okay? Each problem will have 4 points. So if you get that, I guess you will just get 2 points. It's very valuable 2 points, right? 50%. Make sure I squared is -1. Okay. And then you simplify it. At the very end, you would like to write it as a plus bi form, if possible, which is 7 over 29 plus 26 over 29i. How many of you got this right by yourself?
I have a question. For 26 over 29i, is it okay if we further simplify that?
Okay, how do you further simplify that? Divide it by 3. How do you divide it by 3? 29 is prime. No. Well, it's a good try. I mean, it's always good to think about simplifying. Okay, any more? How about number 3? Number 3, you have a radical equation, okay? And you need to isolate one radical on one side. Is that right? Okay, so after you isolate it, you square both sides. And the other side, you need to have a complete square. Did you get that right? The middle term, did you get the middle term right? Yeah. This is the place most of students missed. And very often, it's 4 points off. Because if you cannot get this complete square correctly, people would know you're still not very good in FOIL or distribution. Okay? So probably you just get 1 out of 4, unfortunately. And you square both sides. And then, okay, wait. Go back. Here, you still have 1 radical, so you need to isolate that, right? Okay, after you isolate it, you square both sides. Now, this is a problem. I don't know why. Some people cannot do this. Can you tell me how do you do this square? 2 times 2 is 4. And then radical a plus 4 times radical a plus 4 is what? A plus 4. Is this hard? No. Okay, I'm glad. All right? And then you just solve the quadratic equation. Make sure that you would like to factor one side and the other side is 0, right? Okay, and after you factor, you got a equal to 0 or 12. Now you need to check. What do you need to check? You need to check whether the radicand is greater than or equal to 0. So you need to check for both. For a equal to 0, does it make both radicand greater than or equal to 0? The first radicand is 2a plus 1. You can use a mental math, okay? I don't mind if you don't show it, but you have to check it, okay? Because a lot of time, it may not be true. So for a equal to 0, yes, it is positive. For a, and then for this, yes, it is positive. Do you see that? Or you write it out. Does it make it greater than or equal to 0? For a to 12, a equal to 12, does it make it equal to or greater than 0? Yes. How about this one? Yes. Now you need to check whether you make the equation true. For a equal to 0, plug in 0. Plug in 0. Okay? What you get is 1 minus 2. Is that equal to 1? It's not. So a is not a solution. How about a equal to 12? Well, you will get square root 25 minus square root of 16. Is that equal to 1? True. So the answer will be 12. Okay? Set solution. Is this okay? How many of you got this right? Raise your hand. Yay. If you didn't get it, have you got it now? Yes or no? Is this hard? A little bit, huh? Okay, now I want you to, I don't have time for another quiz, but then I think this is a very, very important part for you to practice. Okay, we are going to continue for our 8.5. Before I show that, can I have you look at this, okay? Do it on your own notes. Do it on your own notes. John needs 3 hours to do a job, and Mary needs 4 hours to do the same job. How much time will it take them to finish the job if they work together? If they work together. Okay? We have done this last week, so you need to think, what kind of problem is it? It's called working together, right? They would like to work together. They would like to work together. So what should we do? We need to figure out how fast for each of them in 1 hour that they can accomplish. How much work John can do in 1 hour? Can you tell me? If one job is considered as a big, big, big whole pie, yes, he can finish 1/3 of the job. How about Mary? Mary can do 1/4 of the job. So yes, this is something that we have to think when we encounter this kind of situation. When you work part-time or full-time in the future, at the work side, sometimes you have to work together with your colleague, right? Your coworker. So if you want to work together with someone, you have to find out how fast that person can work, right? Okay, so if that person can accomplish job in 3 hours, that person's speed of working is 1/3 per hour. She can finish a job in 4 hours, so per hour she can finish 1/4 of the job, right? So now they are going to work together. So, you know, it falls into the distance model, right? Rate times the time equals to, now it's not distance, now it's what? The work. Okay? So I'm going to organize the data. For John, the rate is 1/3 per hour. For Mary, the rate is 1/4 per hour. They are going to work together for some time. I don't know how much time. So it's unknown. So I call that variable t. So after t hours, John can work how much? Every hour, he works 1/3 of the job. For t hours, he multiplies by t, right? So 1/3 times t will be the part of the work he can accomplish after t hours. For Mary, she can accomplish 1/4 in 1 hour. So for t hours, she can finish 1/4 times t, that much of the job. And you expect what? They can finish the whole job, right? So it means the work done by John plus the work done by Mary should be the whole job. What do you mean the whole job? It's a big one, right? One job. Is that right? How much John can do? This much. What is that this much? 1/3 times t. How much Mary can do? In t hours, she can do 1/4 times t, right? So what is that 1/3 times t? It's t over 3. Is that right? What is 1/4 times t is t over 4. So do you see that? That is the beautiful model, right? The work done by John plus the work done by Mary is the whole job. Does it make sense now? How do you solve this? Well, this is back to your pre-algebra. This is an equation involve rational, involve denominator. What would you do? This is an equation, so what? You can multiply both sides by the same number and it's still equal, right? So what would be the number you want to multiply? 12. That is the LCD, right? So you multiply 12 on both sides means you multiply 12 with every term. So you multiply 12 with every term, multiply 12, multiply 12, multiply 12, and you get what? 4t plus 3t equals to 12. Do you see that? Okay. So that means 7t equals to 12. So t equals to 12 over 7 hours. Here comes a mom, try to have a bike assembled by you and your coworker. And she asks, how long should I wait to get the bike? Well, you answer, oh, you need to wait 12 over 7 hours. She's going to laugh. What do you mean by 12 over 7 hours? You need to tell her what? How many hours and how many minutes, right? So when you get this, you usually would like to convert it to hours and minutes. So how many hours and how many minutes? It's 1 5/7 hours. How many minutes is 1 5/7 hours? How many minutes for 1 hour? 60. So you need to calculate, convert 5/7 hours is 5/7 hours times 60 minutes. Is that right? Okay. Does it make sense? Because 5/7 hours, that is in terms of hours, right? But 60 minutes, that is 60 minutes per hour. So 5/7 hours times 60 minutes per hour, then you can see the units hour and hour will be divided out. So that's why you get minutes. Does it make sense to you guys? Okay. So it's about 300 over 7 minutes, which is 43 minutes approximately. So you say it's 1 hour and 43 minutes. Okay? All right. Is this hard for you guys? It's okay, yeah? Okay, good. Now we are going to look at the Chapter 8.5, which is solving logarithmic equations and exponential equations using properties of logarithmic functions, okay? All right. What is this? If log with the base a of m is equal to log with the base a of n. Look, are they having the same base? Yes. If they have the same base, you are very, very happy because you are comparing two functions with the same base, right? And remember, log. What is the shape of log? Can you tell me what is the shape of log? Log would pass 1, 0. Am I correct? Log with any base of 1 is 0, yeah? And if the a is greater than 1, it is what? Increasing. So log with the base 2 of x, like this. This point is 1, 0. And this point, this is 0, 1, right? What I'm doing? I'm doing this exponential, sorry. This is 2 to the power x, right? When x equal to 0, it is 1. When x equal to 1, it is 2. This is exponential. What is a log to the base 2 of x? Well, it is symmetric about this 45-degree line, remember? Yes, good. And then when x equal to 1, it is what? 0. Yeah? When x equal to 2, it is what? What is log to the base 2 of 2? 1. Right? What is log to the base 2 of 4? Hello? 2. Got you. This. Right? What is log to the base 2 of 1/2? It will be -1, right? Remember? Yes? So log is something like this. When you go home, always try to do that yoga exercise. This is log, okay? And this is exponential. They are symmetric about the y equal to x line. Okay, now, if you have two log functions, they are having the same base because log is increasing. That is 1 to 1. So if output are the same, input must be the same. So if log, so in other words, if somebody tell you that I have log to the base 2 of 2x minus 1 equals to log to the base of 2 of 5. Then you say what? Well, since you have the same base, right? And log is 1 to 1, remember? Different input will go to different output, right? So if you have the same output, your input must be the same. Is that okay? Yeah. So that's what it says. If output are the same, then input must be the same. Okay? That is a very, very important 1-to-1 property. One more time. What do you mean by 1-to-1? What do you mean by 1-to-1 property? 1-to-1 property. What is 1-to-1 property? What is 1-to-1 property? 1-to-1 property. If you have a function that is 1-to-1, means what? Different input go to different output, right? Okay? So they are different, so the output are different. If I tell you that they are having the same output, then you would say, hey, because different input will get you different output. So if you have the same output, then your input must be the same. Of course, right? This is logic. Okay, so 1-to-1 property is a very, very beautiful property. Okay, so now let's go back. So what does it do for us? If you have this equation, log to the base 5 of 1 equal to log to the base 5 of x minus log to the base 5 of 8. Uh-oh. So many logs. What should you do? You make sure that this has 1 log. And on that side also has 1 log. But you have 2 logs, right? This is the difference. Can you combine it become 1 log? Yes. This is different. So you can use what rule? Quotient rule. So you become what? Log to the base 5 of what? X over 8. Very nice. Only 1 log. Okay? Only 1 log. Or some people say, you know what, Dr. Chen? I'm not that good in quotient. I'm not that good in subtraction. I'm good in addition. So a lot of people say, I would rather put this on the other side so I will have addition. Now, this is addition of 2 logs, so it become a product. Are you with me? Okay, so you will have log to the base 5 of what? 1 times 8. What is 1 times 8? 8. So you will have, or you can just use 5 to the base 5 of 1 is 0. Okay? Therefore, you get 8 equals to x, right? Because what? Log is 1-to-1. One more time. I'm going to upload this on Canvas for all of you. Okay? tomorrow you will have a quiz, something like this. You are going to state what is being done for each step, okay? Check. If you got this answer for log, remember log. What is the domain for log? What is the domain for log? Remember, this is your yoga action for log, okay? For log, what is the domain? Has to be greater than or equal, greater than, not equal to 0, right? See? 0 has no definition, right? For the log, x has to be greater than 0. So you have to see whether this is greater than 0. Is this greater than 0? Right now, x equal to 8. Yes, it makes it greater than 0. So this is okay. That is the first check for the domain. The second check, would that make the equation true? So you plug it in. And you find out you make the equation true. Okay. Second equation. What do we do? Okay. You can use the quotient rule. Combine these two logs into one log of a quotient. I will give you warning. Warning, warning, warning. This is a log. How many log you see? 1 of a quotient. Instead of putting log in the denominator and log in the numerator. Does it make sense? You combine a difference of logs into one single log of a quotient. Okay. All right. So you can write this using exponential. So this is a base. This is exponent. And that equals to this. Does it make sense now? Okay. I will pause here a little bit. How do I write a log expression to an exponential expression? This is my base, that's my exponent. So 3 to the power 2 equals to this, right? Yes or no? So now 9 equals to this. Well, you can solve that, right? It's a rational equation. So 9 times x minus 1 equal to that. So you just distribute it and solve for x. Am I done? No, you have to check. You plug into the argument. See, is that greater than 0? Yes. Okay. Is that equal to greater than 0? 3 minus 1 greater than 0. So it's okay. So domain-wise, it's okay. But you still need to check whether that make the equation true. So you need to plug it in. Oh, yes. It is log to the base 3 of 18 minus log to the base 3 of 2. It becomes log to the base 3 of 9. So yes, it is true. Does it make sense? Yes or no? Yeah? Question. You can ask questions. Okay? All right. How about this one? Would you like to do it yourself? I'll give you 3 minutes. Everybody. .5. After 8.5, we are going to do the whole chapter 7. 7, 1, 2, 3, 4, 5, 6, 7. All right. 3 minutes. Yes. You only have 2 more. If you're done, raise your hand and I will check. Show me your checking. You have to show me the work of your checking. We will give them back all the exams. Okay?
Is this a correct approach?
Yes. Where's your problem? You should write down your problem. I don't know what is that. No, this is not right. This is not right. You did not write down the problem, so you confuse yourself. Yes. Or, you should say or here. Or, and then 1 is not.
No, it's not. I got a negative.
Okay, so you need to answer in solution set. Okay, so now let's see. You will have log x plus 3 times x, because using what rule? Product rule, right? Now you have one log on one side, the other log on the other side. They both have the same base. What is the base for now? What is the base? 10. So by the 1-to-1 property, what is the property? Can all of you say what is the property? What is the property that we use? It's 1-to-1 property, right? Can you all of you say out loud? It's a 1-to-1 property, right? So the 1-to-1 property we use here is what? If output are the same, then the input must be the same, right? Okay. All right, so now you can solve for x. This is a quadratic, so you want to put everything on one side and then set the other side to be 0. And we can factor, luckily, so x equal to 1 or x equal to negative 4. And then what you need to do is just what? Checking, right? Okay, let's check. Let's check. Okay, since you know x equal to 1, is 1 okay? Well, 1 will make the argument all positive, so tentatively okay. But will 1 making the equation true? Will 1 making the equation true? If you put 1 there, log with the base 10 of 1 is 0, right? And log with the base 10 of 4, yeah. Does it make it true? Yes. How about negative 4? Can x equal to negative 4? No, because it's not in the domain, right? Negative 4, that cannot be negative 4, right? If you put negative 4 here, that is also negative. No, sorry. So, only answer is what? Only answer is 1. So, you will answer using the solution set. Do you know what I'm saying? Using the solution set, you are going to write this way, okay? The answer. Okay, now this is exponential. This is exponential. How do we solve it? Well, you try to convert it to a logarithmic equations. Does it make sense now? Five to the power x equal to 23. What is x? Okay, now you need to do the next step. I'm not going to help you. What is log to the base 5 of 23? Can you solve it? Okay, now everybody, you have 1 minute to solve it. You can use your calculator. Do it now. You have to use what? Change base formula, right? What is the change base formula? In your calculator, you don't have base 5. You only have base 10 or base e. Very good. But what is that? You need to use change base formula. Do you remember change base formula? Yes?
No, I don't remember it.
Oh, good. You have to dig it out, okay? Whoever can get the first, you will get double or triple points. Did you get that? Yeah. What is that? What is that? You have to find, no. Change base formula, find it. What is the change base formula? Uh-oh. Has been some time, not too long ago, right? only like 2 weeks. How could you forget your good friends? Oh, you're awesome. What is that then? Using your calculator. Well, you got it right. You got it right. Congratulations. But what is that? Use your calculator. What is that? How did you find it?
23 log divided by 5 log.
Say it again. Write it down. Write it down. How do you write it? Good job. No. Oh. That is a common mistake. You have your textbook, okay? It's not that you don't have your textbook. Did you get that?
I gave up absolutely.
Try. You have to try. How do you get that? It should be 23 on top. Log. This is something that you have to always change your base formula, okay? If you have log to the base 5 of 23, I can write it as a log 23 over log 5. That means what? They all have base 10. Or I can write it ln 23 over ln 5. Does it make sense? Okay? How many got this? Raise your hand. Okay, good. I'm very proud of you. If you forget about that, be careful. This is going to be very important for your final exam. Okay? How do you try to figure out a number? The base is not 10 or e. You change the base. Okay? All right. Now, that's how you do it. So the answer is 1.948 approximately. Okay? No, you have to give some. Okay, now how about that one? Well, obviously, you will write it as a log, taking log on both sides, okay? And then the exponent, remember, you can go go out as coefficient, right? And now you can, what you can do, I'm going to pause here. When you have exponential functions, exponential equations, okay? The variable is high in the sky. Well, I use that to describe that it's in the exponent. How do you bring it down? How do you bring it down? Go down. You take log. You take log on both sides. Because they are equal, can you take log on both sides? Yes, they still equal because they do the same thing. But because this is exponent, we have power rule, right? Then you can equivalently rewrite it as 3x minus 2 times log 15. You just need to distribute it, or you can, because right now this is a number. Remember, this is a number. So you just divide it down on both sides by log 15. So you get 3x minus 2 equal to this. So what is 3x? You add 2 on both sides. So your x, it will be about 1.336. Is that okay? All right, so go back. Just want to let you know, to solve this, this is a number, right? Divide by the same number, you get that. Then you can solve for x. Does it make sense now? Okay, this is the problem that showing you how to make use of the log to solve exponential equations. Okay? So far, okay? Okay, now we are going to talk about money now. If you deposit some money in the bank, okay. How many of you have checking account or any investment? So you have, this kind of calculation that you have to take care. I did have a friend. We were at UCLA. Yeah, we all in this PhD program. And one time she came and told me, you know what? I found a bank on my bank statement. I said, are you sure? We usually trust the bank statement, right? We did not even bother to check. No, I check it. She has a lot of time, obviously. I checked my bank statement. She didn't trust that statement. I found a mistake. I say, so what did you do? I went to the bank and asked for whatever that I should get. So anyway, obviously she tried to find out how much she should have in her bank, her account. And this is this is what we have. If you have so much money put into the bank, and the rate is R%, okay, R is the rate annually, and what is N? N is how many times that you compound your interest, okay? Did you learn this before? How many of you have learned this compound interest? Okay, great. So I will describe this tomorrow because we don't have that much time. But I will have you say, if this is given, and I will give you on the exam, okay? So I give you this formula. This is a formula for you to find the account balance. If you have interest compounded, what do you mean by compounded? I put $100 in the bank. Every month, I will earn some interest, right? If that is simple interest account, then the interest is not going to make more money. But when you say compound, means the interest is going to put into the basket of your principal and making money. So it's the interest making money as well. What did I just say?
The compound is the accumulation of the rate. What?
The compound interest. We all love compound interest. Think about this. I make some interest. If the interest just sit there, it's not going to make more, right? But go to the bank, you say, I want compound interest. Means what? Every month, at the end of the month, the interest is going to come into the original account, and that is going to make money. If that is simple interest, then sorry, the interest just sitting there, idle. Okay? Okay? Compound interest means the interest is going to make interest. Anyway, that is the formula. And we wonder, if you have 25,000 and that gives you 4% compounded monthly, how long will it give you $4,000? Say that you would like to go for a vacation and needs $4,000. How long you need that 2,500 sitting in the bank with 4% compounded? So you say, well, I know the principal is 2,500. My outcome, my dream is to get 4,000. My interest rate 4% is 0.04. And it's going to compound it monthly. Means what? Every month you are going to compound, right? So you need to solve for T. Okay, A is the final money. P is 2,500. 1 plus 0.04 over 12 to the power NT. N is 12 times T. You want to find T. How long, right? That is high in the sky. What would you do? You would try to what? Making use of log. But before you do that, do you see that? This is what? 2,500 times, right? So I would like to divide both sides by 2,500 first. Do you see what I'm saying? Okay? And you will get this. Okay? Divide 4,000 by 2,500, you get 1.6. And this is 1.003 to the power 12t. So how do you find this? I take log on both sides. Okay? I take log on both sides by the 1-to-1 property. Now this 12t in the power will come out to the front, right? So you have 12t times log 1.003 on the right-hand side. How do I find t? T is the one that I need to isolate. So you just divide both sides by 12 and this, right? So 12t, you divide both sides by log 1.003, 12t equal to this. So what is t? Divide both sides by 12. Okay? All right. So you say, what is that? If you would like to put some money in the bank or invest in mutual fund, okay? And that mutual fund will give you some kind of rate annually, okay, and compound for some time. If I compound it quarterly, means compound how many times a year? 4 times. Then n equals to 4. If I compound it every minute, you would love me, right? Then I compound how many times in a year? 365 times a year, because I compound it every day. Is that okay? Then the n would equal 365. Here, 365. Okay? All right. So I'm going to collect your quiz, and also I'm going to give you the exam. Brianna? Okay, Christina? Shang, Yao? Thomas? Not here? Daisy? Izo? Some of you did very well. I'm very proud of it. 1. Okay. Audrina? Come. Roseanne? Claire? Fanny? You need to do the correction, and I will give you a makeup exam. That will be on Thursday. Thursday after this class. Okay. Yeah, I think Thursday is better for you. Okay. Chong Hong. Stephanie. Oh, by the way, remember the homework will be 8.5 and you have pre-reading. It will be on Canvas and also correcting this. Catherine? Is Catherine here? Okay, try to work. Okay. Aaron? Is Aaron here? Nathan? Drop. Brenda? Oh. Sarina? And also, here. Shangzi? Shang Y? Catherine? Oh, I'm so sorry. Is that okay? Did you get that? Fan Yi? Yeah. Fan Yi. Sakurai? Okay. 1. V. Thomas. Roseanne. Cynthia. Is Cynthia here? Chunkit. Claire. Changheng. Sarina. Brenda Rubio. Audrina. try to correct it, okay? Daisy? Daisy. Is Daisy here? Izo? Yes, okay. Try to correct it, okay? Sergio. Correct it, okay? Stephen? Okay. Yes. That's a quiz today, yeah. Sorry?
I took my course on Friday, but you said since I was missing some of it, that you were gonna let me retake.
You take what?
The quiz, because Friday
What quiz?
the answers were, the thing was wrong, so you said you were gonna let me do number 2, because my question was cut off, it wasn't there.
Oh, okay. I will let you do it on Thursday. Okay?
Dr. Chang,
Yes.
I have a doctor appointment,
Uh-huh.
so can I start my test now?
When are you going to see the doctor?
Today, right
Today.
now. I
Oh,
have
you're
like-
going to see a doctor.
Yeah, I have a massive headache.
Oh,
yeah.
you want to? Oh, poor girl, poor girl. You want to
No, but-
take? You want to take it on Thursday? Would that be better for you so you have
No,
more
I
time?
think today.
You think today?
Yeah.
Okay.
this is today.
All right.
Last time I wanted to sign up for the makeup program, so may I take it?
Now? Yeah.
No, Thursday.
Yeah, Thursday. Sorry?
What is it out? The total score?
This is 100.
Okay, that's fine.
This is 100. Yeah.
You want us to break it?
Oh, yeah, of course. You have to correct it. Every time you get that, you have to correct it. Yeah. Okay. Which one?
Mine says 110 on it also, so I think.
Okay.
Or is this one the 100?
No, actually, this is out of 90. Yeah, 90 plus 110 is 200. Okay? Yeah. So now you did very well. Okay? So continue your good work. Okay? Izo? Yeah? Good.
I haven't got my test.
You haven't got your test? Did you